this, we have a terminology for that called rigor mortis. Same as Dr. Mort's last name, called rigor mortis. Acronym, we just write OM, coming from a Latin word, equals stiffness of death. So, this seems like very smoothly happened. But this stiff of death rigor mortis is not happened immediately. They'll generate lots of the drama and trickiness. So we're going to talk about that. We're going to draw the curve right here. Okay. X-axis is time. Y-axis we're using shear force value. If you kill an animal, you kill a beef, the rigor mortis, which means RM, does not happen immediately. What happens? Very similar to a growth curve, like this. And there is a time period, it's delay stage. And there is a period of time here, is called rigor mortis completed. And then later on, it actually will become this. This is called resolution. Now, why these things will happen? So it's very similar to a bacterial growth curve. Why these things will happen? So we want to talk about this delay stage. We also call it onset stage. Okay? And we mentioned, after the blood depletion, ideally there is no ATP. However, most of the time, there is a limited amount of ATP still will generate from creatine phosphate. So ATP will be temporarily generate. Once the ATP temporarily generate, the contraction and relaxing still happens in a period of time. And this period of time is tricky. So we talk about onset time. So let's first talk about beef. Beef, the onset time is longer, 6 hours to 12 hours. How about pork? 3 hours. Now chicken and fish, we don't have to worry about. Chicken and fish are very short, both less than 0.5 hours. This comes a question. Lots of the small producers, they slaughtered the beef. They wait for only 2 hours, go ahead to cut. The cattle's temperature is still very high, and ATP is still present. Then what's going to happen? The calcium will be dramatically released from the sarcomere, so will cause shrink, the muscle shrink. That is kind of like a cold shortening. So we will mention real quick, okay? So that tricky thing is here. Okay, then later on, this is not going to happen very often, okay? When the creatine or creatine phosphate is gone, then the ATP is gone. So happened is rigor mortis. But how come there's a resolution happened? This you need to go back to here. Remember, we talk about the Z line. This is the Z line. The Z line is not alone. There has been circulated or attached with lots of the protein. We mentioned nebulin, titin, desmin. There is some enzyme can break them. That's called calpastin. Let me make sure it's a prolytic degradation, calpain. Okay, we call it a calpain. And the calpain is rely on calcium. There are two different types of the calpain. We call it mu calpain and M calpain. Basically differentiate based on the requirements of the calcium amount. The micro calpain, basically we need 50 to 100 micromolecular. And the millicalpain, we need about 1.5 to 2.5 millimole calcium. They need the calcium to activate it. The calcium, where they comes from? They comes from the sarcomere reticulum. Now, another thing we also want to mention, if you have a beef, let's say, you already cut it. This beef, more or less, will still have some calpain. So what we do, there is a kind of powder you could buy, which is called a tenderizing powder. And those powder is very simple. It's actually calcium powder. And with the beef, we could do is a cold temperature storage. We call it aging. Or do the vacuum package. It could be Arabic or a vacuum package. There's a separate dry aging and wet aging because we want the calcium could be completely released from to activate the calpain. And the calpain will be, we call it the endogenous chemicals in the muscle. Even the muscle has been cut, they still have some residue among them. Okay, so that's a calpain. Now, this generates the problem in the beef industry, in the cattle industry. In the body, more or less, has a calpain inhibitor, which is called calplastin. So people will do a different breeding, which means and hybrids with different breed of the cattle. In Florida area, back in 1905, there is a meat scientist called Dr. Zimpoma. He did a different combination of the breeding. He finds there is one type of the beef, we call it Bos indicus. This type of the cattle has a huge amount of the calplastin, which means they could be inhibited the calpain generate. That means the muscle will be very tough. So those type of the muscle usually only do animal labor by the time. Now, later on, people want to generate a meat. So they do on and on, lots of the work. Until very recently, I will say like 30 years ago, people find there is a breed which has a minimum amount of the calpastin and have a huge amount of the calpain. What is that? That's Angus. That's the reason when you go a restaurant, you go fast food restaurant, you always will say, I want to order an Angus steak, because that's a breed which has a minimum amount of the inhibitor. But however, this is what I learned from my students. Angus breeding, as long as you more than 20 to 25%, you could label Angus. It's not really 100%. If we do a shear force value of the beef, Bos indicus shear force value is 5.9. Angus is only 4.1. So it's a huge difference. Almost like 30%. 30 to 40% of the more tender. Okay, so this is what happened. Now, the last section. We know about that. Today, we have a very standard beef harvesting and slaughtering processing in the United States. We could generate a very tenderized beef. But in the history, we had some problem, which is had a problem with cold shortening. Now, this cold shortening problem actually is not found in the United States. This is kind of back in 90. Let me double check the number is correct. This is back in 1960s in New Zealand. New Zealand Meat Institution. They received a lot of the complaints by the time. They said the lamb is very stiff. You cannot bite it, it's very tough. That's a problem with the cold shortening. So what's a cold shortening? Cold shortening could cause a shrinkage of 80% even, the muscle. This is I just briefly mentioned, which is you chilling a beef below 15 degrees Celsius. New Zealand, they use an international degree Celsius temperature units. ATP still present. At the same time, rigor mortis not initiated, which means not even started. What happened? Calcium dramatically releasing from SR. Once the calcium is dramatically releasing, the troponin C will be along tropomyosin to find the myosin actin, have an actin myosin cross bridge setup. So the muscle is become relatively very, very tough. Okay, so in order to do that, what we should do, didn't organize very well, what we should do, there is several things we can do. Number one, slow chilling. This is very important for small producer because they always want to sell immediately. Slow chilling. Make the cut after rigor mortis. And you could cut right here. Okay, not right here. Not even here. The second one. Did you ever notice that if you have a cattle, when they hang in the stall, what they usually do, the leg is on the top, the carcass is at the bottom. This is called stretch tender. We call it arceus. I need to make sure the spelling is correct. This is called suspended with arch bone, not archless tendon. Not archless tendon. So the always which is hanging around is upside down. Now last thing what they do. Electronic stimulation. Acronym ES. Electronic stimulation has two different levels. You could use 500 voltage, which is high electronic stimulation. You could also use in 30 to 60 voltage. With a hertz, usually 50 to 60 Hz. Now, what's the function of these? Number one, we need to let the calcium, we could say this, we need to let the calcium appropriately release from the sarcomere reticulum. So, appropriate amount of the calcium to release. Second, we need to speed up glycolysis. We want glycolysis to speed up. Because the glycolysis speed up, we could let the meat reach 5.5 or 5.6. So this part of the job, you could be finished. And directly to go to the next step, which is active myosin cross-link habit. And this is the one, how long it's going to do, what's the level of the voltage. This has lots of the validation study to verify it. The last thing, especially you're using this 500 voltage level with 50-60 Hz, this will cause a very strong physical damage of the tissue. So, which means the Z line here, this protein could be contracted and could be damaged. And also the active myosin here, this cross-linking could also break down if you're using a very high voltage. So that's why in the United States we do ES very frequently. Okay, so this is the whole story, which is talk about meat tenderization. And there's lots of the chemistry behind it. And I'll talk about it relatively short. Because if it's a meat science class, and Dr. Kenny could talk about this a week. There's a lots of the chemistry behind that, especially like this part. I go relatively brief. There's a lots of the story I could talk about here. Okay, but this is the whole thing when we talk about meat tenderization. The key thing is muscle contraction and the muscle relaxation. Now, related to the meat tenderization, there is another theory which is talk about the collagen. So we need the meat has a relatively appropriate amount of the intramuscular fat, because they think the intramuscular fat called the shrinkage of the collagen, and then will let the meat become more tender. So therefore, you have a different marbling score like prime, selective, And this related to that, we will talk on Thursday about the collagen, and also related to the tenderization. There is a two topic, which is PSC and DFD. We'll talk on Thursday, and also Thursday I will return the exam paper to you guys. There is a two question I want to mention to all. Okay.